Hello and welcome to math. Today we're doing lesson 5, half turns and quarter turns. We have a few learning goals to look at. First, we want to be able to rotate geometric figures on the coordinate plane 90 degrees, 180 degrees, 270 degrees, and 360 degrees. We also want to be able to identify and describe the effect of geometric rotations on 2D figures. And we want to be able to identify congruent figures by obtaining one figure from another through a sequence of transformations. There's a lot to think about there. But before we move on further, let's do today's warm-up. So for today's warm-up, we have 3 questions to look at. Here they are. Well, really, it's just one question with 3 parts. Question 1 here. The first one, part A, asks us to turn this figure 180 degrees. The next one asks us to turn a figure 90 degrees counterclockwise. And the next one wants us to go 90 degrees clockwise. We can do that. And this over here, ignore that. That's just something I accidentally copy and pasted into this slide. So what you're doing is the warm-up, which is in this box right there. And that should take you about 5 minutes. So let's set a timer and hit pause and draw some figures. Your teacher will be checking for understanding while you work through today's warm-up. Well, you've hit play, so that must mean that you are ready to talk about the warm-up. Well, before we really dig into this warm-up, you probably want to know the difference between clockwise and counterclockwise. These two GIFs, or GIFs, whatever you want to call them, illustrate the difference between clockwise and counterclockwise. Take a second and look at them. Okay, now I would like somebody from the class to explain the difference between counterclockwise and clockwise. Pause the video and listen to your classmate who is ready to explain the difference. All right, excellent. As you talked about, the clockwise means that the clock is going in the same direction that a clock goes, or a rotation is going the same way that a clock normally goes. Counterclockwise just means going in the opposite direction, opposite of a clock. If you ever forget, just look at a clock, and that's all you have to do. So let's go back to our warm-up now that we've talked about that a little bit and see if we can rotate these figures clockwise and counterclockwise. I'm actually going to work backwards and start on example C with our 90-degree clockwise rotation. That would mean that it's 90 degrees that way. That's the clockwise direction. Now here's my drawing. You can see I've taken this rectangular prism and I have rotated it 90 degrees clockwise, and now it's on its side, and the shaded part is on the bottom. Now let's work with that cylinder. I really want to work with the space to the left with the cylinder because it's going 90 degrees counterclockwise. So it should look something kind of like that. It's rotating 90 degrees counterclockwise. Now what about 180 degrees? Sometimes it actually helps to do 90 degrees first and then do 90 degrees more, because 90 plus 90 is 180. So two 90-degree rotations would be the same as one 180-degree rotation. Let me erase my middle step there. And this is what it means to rotate 180 degrees. And a 180-degree rotation is the same whichever way you go, whether you go clockwise or whether you go counterclockwise. That's what we're really going to be digging into today, looking at rotations, their degree, and their direction. And we have an essential question. We've learned about rigid motions, translations, rotations, and reflections. Today we want to ask, how can we model those? How can we describe them not just on patty paper or on a sheet of blank paper, but on the coordinate plane?